What's up, guys? Welcome back to another one. And today we're going to be talking about, well, first of all, I'm going to be covering all month, they're going to be covering STEM. And it also happens to be Black History Month. So the two will go hand in hand. And, you know, can't really talk about STEM and Black history without mentioning George Washington Carver. And I'm going to do a little reading about him. For those who don't know, he was one of the prominent agricultural scientists of the 20th century. And he's very well known, internationally known, for revolutionizing agriculture using 2 to 3 products: soybeans, sweet potatoes, and most notably peanuts. The man made literally over 300 different kinds of products and uses for peanuts alone.
George Washington Carver was born a slave, but with hard work and education, he became one of the most famous scientists and inventors in American history. You may know him as the Peanut Man.
Up in the sky, it's a scientist, it's an inventor.
No, it's Peanut Man.
Peanut Man! That's because George Washington Carver invented over 300 products from peanuts, including peanut milk, peanut plastic, peanut paints, dyes, medicine, soap, ink, and wood stains. You could say this guy went nuts for peanuts. See what I did there? Nuts? Peanuts? Anybody? No? Anyway, George Washington Carver didn't just work with peanuts, he also invented 118 products from sweet potatoes, like sweet potato molasses, sweet potato glue, flour, vinegar, rubber, and even sweet potato gasoline. Carver was so respected, he met with 3 American presidents, including Theodore Roosevelt, Calvin Coolidge, and Franklin Roosevelt. He also became the first African American honored with a national monument. This was the first national monument dedicated to an African American and the first to honor someone other than a president. George Washington Carver used his fame to teach others about farming and science. He also encouraged others to treat people from all races with respect. So, let's hear it for George Washington Carver, a scientist who made big inventions using a tiny peanut.
Yeah, honoring this great ancestor of ours, and I am going to do, in honor, a brief experiment using, not peanuts, but using a smaller, sweeter, delectable, can't even see it, but it's Skittles. And with these yellow Skittles, I chose yellow because that was like, they had the most, that was the most popular color in the bag. But we're gonna put these yellow Skittles into a solvent. A solvent is basically any liquid that can, that is meant to dissolve a solute, which I believe any material that is dissolving in the water is a solute, and the solvent is not the water but the liquid. So let's check out the experiment. All right, guys, so let's arrange these cups. I have 5 cups of different solvents, and we're going to see what happens when we put for quite some time. I'm not going to just leave them in there for a minute. I'm going to put them in there for, I'm going to say, an hour. I'm going to document what happens to these Skittles, our solute. So in our first cup right here on the left, we have This is, oh, it actually looks very similar to this cup, but I remember because I put this one on this side. This is apple cider vinegar. I'm going to put 1, 2, 3 of those in there. Right here, we have this blue solution here that is Listerine. So I want to put 3 of those in there. Here we have plain old, good old water. Right here we have, in this cup, is extra virgin olive oil. So there we go. And right here, last but not least, is what is this again? Oh yeah, it's ginger lemon tea that I prepared. So ginger lemon tea. Put 2 in there. Put 1 more in the water. Actually, no, I'll put 1 more in the oil, and I'll put 1 more in the water. So, there we have it. Gonna let those react, because basically what we're allowing to happen is a chemical reaction between the Skittles and the solvent. The solvent will do what it does. Maybe some will dissolve, maybe some won't. We'll check back in an hour and see. All right, and we are back. It was originally supposed to be an hour, but I decided, you know what? Nothing is happening as fast as I would like, so I extended it to 3 hours. So this is 3 hours later. Let's check on our chemical reactions. I have my handy dandy LED light. So we're going to start with, you know, and I'm going to need something to pour these solutions out into. So I'm going to use this container right here, because our first solution of the apple cider vinegar is cloudy. You can't even really see in there. We want to find out exactly what happened to our Skittles. So I'm going to pour it out. There we go. Oh wow. Oh wow, look at that. Looks like they dissolved completely. Complete dissolution. I don't know what the word is, but all right, look at that. Good stuff. All right, next solution, our Listerine. What do we have here? Hold on. Yeah, another completely dissolved. But you can kind of see, let's shine the light on it. Oh, look at that. Those are the last remnants of our candy. Wow. Okay, I'm pouring this in. Interesting smell and color. Ooh. All right, next, our water solution. We have, yeah, a lot of breaking down of the original candy. Let's pour it out. Let's see if the entire thing dissolved in water. Completely dissolved in water. That's amazing. I was not expecting that. And of course, here we have our oil solution. Now this, as you can see, is almost unchanged completely. In fact, the colors didn't even run. I'm going to pour this out into another cup. Wow, it's virtually untouched, undisturbed. That's very interesting. Looks like the yeah, colors everything are on there. Looks like the oil didn't disturb it. There's no chemical reaction there at all. All right, and last but not least, we have our ginger lemon tea, which definitely looks like it's been melted quite a bit. So let's pour it out. Ooh, yep, completely melted. Completely dissolved into that. All right, and now we have our radioactive solution. Dare I drink it? Should I drink it? Nah, just kidding, guys. But no, I'm going to pour this out. But yeah, that was a very interesting experiment. And why did I choose this kind of experiment, using Skittles and putting them in different solutions? It's because look at what Mr. Carver was able to do with one plant.